Hey, geometry students, we are doing a short lesson before Thanksgiving break. We're going to talk about triangle congruence, side, side, side. You don't know what that means yet, but you're going to today. Why don't we just go ahead and jump in and get started? So, we want to be able to prove that two triangles are congruent. Congruent, remember, means everything in the two different shapes has the same measure. We want to make sure that. So if we look at these triangles, let's just look at these triangles. We can see that they have these congruence marks. 3 and 3, so those two sides are congruent to each other. 2 and 2, those sides are congruent to each other. 1 and 1, those are congruent to each other. And then same thing with the angles. We've got the 3 marks at T and J. We have the 2 marks at R and L. And we have, have to use light blue again, the 1 mark at K and S. So if I was naming the congruence, if I was trying to name these triangles in a way that they were congruent to each other, because that's what these first two problems are about, just naming them. The symbol for a triangle is a triangle before the 3 letters. And if I named the first one JKL, just alphabetically, do I have to do it alphabetically? No, but if I did, then I have to say it's congruent to the triangle that starts at the same angle. So J starts at the angle that I had said had 3 marks, and T is the other one that has 3 marks. So this one must be triangle T, and then if I'm following the same pattern, K was next, so S must be next. See how they match with the 1 arc? And then I colored over it in yellow, but if L was last, R must be last. And we do this so that we can clearly tell that in order, angle J is congruent to angle T. Angle J is congruent to angle T. Angle K is congruent to angle S. And angle L is congruent to angle R. This actually is the same thing is true of the sides. JL is congruent, that's this side, right? JL is congruent, that's the first and last letter, to TR, the first and last letter on the other one. JK, the first 2 letters, are congruent to ST, TS, the first 2 letters on the other one. And KL, the last 2 letters on the first one, is congruent to SR, which is the last 2 letters on the second one. We write them so that we can use the letters to determine what parts are congruent to each other. And the same thing, we're going to do the same thing on the second pair, but the letters are actually already colored for you so that you can tell. Again, triangle, let's do ABC, is congruent to triangle. Okay, A was red, F is red. We can tell it has 1 arc, A has 1 arc. B is blue with 2 arcs, E is blue with 2 arcs, so FE. C is green with 3 arcs, D is green with 3 arcs, and the arcs are going to be very important to us moving forward because we won't have it color-coded every time. But using the arcs, we could tell what parts were congruent to each other. Now, one of the things, so that was, we had on this, we had all 3 sides and all 3 angles marked, and that was how we knew the triangles were congruent. But we also, if we know certain things are congruent, we don't have to know everything, because if these things are congruent, everything else has to be congruent. So, the first theorem, the only one we're going to learn before the break, is side, side, side. And it says if all 3 sides are congruent, then the triangles are congruent. We don't need to know anything about the angles. We're going to be able to actually prove the triangles are congruent just based on the sides. So, help me out here. If I've got KL, And the way these are, it looks like they kind of would like fold onto each other. If I've got side KL, well, according to the marks, that is congruent to NL. Why did I do NL instead of LN? Well, it looks like K and N are the same, so I want K and N at the same points as each other. Then, based on the marks, KM is congruent to NM because they have 2 marks on each other. And then I say, oh, okay, well, LM on the left one is congruent to itself, but if I say it in the order that would make sense, ML on the right one. So as I'm naming the first one, I'm going to name it down the one-sider, up the two-sider. Do I have to do it that way? No, I'm just trying to explain what I'm doing. So to write the congruent statement, triangle L to K to M. Now I have to do it the same way on the other one. Down the 1 marker, up the 2 marker is congruent to LNM. Angle, triangle, LNM. And now I can see, and I guess I should have done this differently. I should have done that as LM, because it's LM on both. The parts of the triangles match up. And that's all there is to it. If all 3 sides are either marked or they have a way that we know they're congruent, like they're the same side, same as itself, we have congruence. We know there's congruence. So this one is going from the statement to the shapes. So we're going to draw 2 triangles that are about the same size. They tell us triangle ABC is congruent to triangle XYZ. To do this right, we need A, B, C, and X, Y, Z in the same spots. And then we need to mark ourselves that A, B, and X, Y match up, B, C, and Y, Z match up, A, C, and X, Z match up. And we could do the same thing with the angles, but that's not a requirement right now. So for side, side, side to be true, we also want to know, okay, what would I need to know? What extra information would I need to prove that the triangles are congruent? So for this one, the sides that I would need to know are congruent. If I do this right, so see how you got the 2 on the R side and the 3 on the T side? So RT would need to be congruent to, okay, we did the 2 side and then the 3 side. So the 2 side and then the 3 side is XZ. We would need to know that side RT is congruent to side XZ. And we're going to do the exact same thing here. We would need to know that side EG is congruent to side YW. Lastly, a little unrelated, but because it's part of this chapter, and this was a fairly easy lesson, I wanted to bring in something called the third angles theorem. So the third angles theorem is this idea that if 2 of the angles in a triangle are congruent, the third angle must be congruent, because there's only one way to add these numbers up and still get 180. So if I know that this is 90, and this is 90, and the marked ones are both 70, we need to figure out what angle X is. And for both of these triangles, it's going to be the same number. So we're going to do 90 plus 70 is 160, 180 minus 160 is 20. And so both of these are 20 degrees. And then something similar here. We know this is 45. We know this is 80. So we do 80 plus 45 is 125. 180 minus 125 is, I believe, 55. And then 5x equals 55. Divide by 5, x equals 11. Just something a little extra that is part of this unit, but it didn't quite fit in anywhere else the way we were teaching it this year. That's it. You do have an assignment on Canvas. It's mostly side stuff. If you have questions about it, please message me on Canvas. Don't just take a low score if you are stuck. And I look forward to seeing you in the next video. Thanks, and bye.